When we evaluate enterprise IT security, we typically visualize a fortress. The strategy relies on building massive firewalls, encrypting databases, and locking the most valuable assets behind a digital vault door. But that physical perimeter loses its meaning the moment you deploy an agentic AI system. Consider the impact of placing a hyper-intelligent, tireless analyst inside that vault. This analyst doesn't need to pick a lock. Instead, they pick up thousands of shredded paper scraps, and by identifying the linguistic patterns and logical overlaps between them, they reconstruct your most sensitive blueprints in their mind. External physical defenses cannot stop a cognitive entity that already possesses unrestricted internal access. This chart tracks the incoming data crisis. By 2025, global data volume will reach 163 zettabytes, roughly a trillion gigabytes. The risk is concentrated here. 80% consist of unstructured formats like unindexed corporate emails, R&D notes, and meeting transcripts. To monetize this information, enterprises are deploying RAG, or Retrieval-Augmented Generation. RAG is a technical architecture that allows an AI to retrieve specific facts from these internal documents to improve the accuracy of its generated responses. While this unlocks the value of your archives, it also creates a massive, invisible security vacuum. The same system that reads your data to help you also reads your data to expose you. Many IT leaders believe they can secure these systems by redacting sensitive information. They assume that if they scrubbed names, project codes, and financial figures before the AI ingests the files, the data remains protected. That defense fails against large language models. These neural networks do not simply match strings of text. They use deep contextual reasoning to infer meaning. We call this semantic penetration. The AI bypasses static redaction by cross-referencing the logic and causality hidden within thousands of unclassified documents. Take Document A, an anonymous project timeline specifying a high-end microchip. Now, Document B, routine travel logs. Matching R&D travel dates to the timeline narrows the scope. Finally, Document C, a supplier's chat log. Linking these, the AI identifies your exact client. The AI functions as an untiring detective, bypassing traditional string matching defenses to reconstruct corporate secrets through sheer semantic logic. When an external attacker exploits this reading capability, they can bypass your entire security stack without triggering a single alarm. This occurs through OWASP LLM01, known as prompt injection. Prompt injection is a vulnerability where an attacker uses natural language commands to override the AI's original programming. A hacker embeds invisible, malicious text inside a seemingly harmless external file, such as a supplier's PDF quote or a public web page. When your internal RAG system automatically retrieves and reads that tainted PDF to help an employee write a report, the AI encounters the hidden instruction. Because the AI cannot distinguish between a user's data and a system administrator's command, it adopts the hidden malicious text as its new primary directive. The hidden command instructs the AI to ignore its safety guardrails, summarize internal financial data, and transmit that summary to an external server. Your highly capable AI assistant is now functioning as an involuntary internal spy, siphoning data out of the vault from the inside. This raises a vital question. Why does the AI have the technical authority to send internal data to an external server in the first place? This is a failure known as OWASP LLM06, or overagency. Overagency occurs when a system is designed without strict boundaries on what the AI is allowed to do within your network. An AI with overagency is like a newly hired intern who is given a corporate credit card with no spending limit and no requirement for manager approval. In an agentic workflow, the AI doesn't just talk, it acts. It modifies databases, triggers external APIs, and sends emails. Granting an AI agent these unchecked operational powers ensures that a single prompt injection can escalate into a systemic enterprise disaster. This leads to the final collapse: system prompt leaks, or OWASP LLM07. This happens when the AI is tricked into revealing its own core behavioral rules and defensive logic to an attacker. Once an attacker knows the specific rules you've set for your AI, they can map your internal defenses with perfect precision, engineering future attacks that are guaranteed to succeed. Because the threat is cognitive and internal, Traditional security scans that look for malicious code are ineffective. They cannot detect a malicious sentence that looks like a normal business request. Security must move from the perimeter to the action itself. Instead of just guarding the network's edge, you must implement dynamic authorization, where every single API call or data retrieval the AI attempts is validated against a strict, real-time permission set. If you allow an AI to connect the dots across your company without controlling what it can execute after it finds the answer, your greatest technological advantage will become your most catastrophic vulnerability.